Right, it's great to be here. Obviously, I'm talking about sheep pneumonia. So first of all, I'd like to start with my acknowledgement slide, because a lot of this work has been done, and it has been done in meat sheep, but it involves a lot of work by a lot of people. So there's a lot of farmers involved, that we've done a lot of field trials. The people at the sheep work, at the meat works, a lot of coordination going on there. Farm IQ did some of the computer work and actually hands-on getting onto the farm and doing some of the work as well. MSD Animal Health, we've been working with them with a pneumonia vaccine, and then all the ag research people. More recently, Tao Zeng has done a lot of work. Tao doesn't work for ag research, unfortunately, anymore, but he did a lot of the earlier work that I'll talk about today. And then before that, it goes back to Bryce Buddle, and he was back last century, but he's still around. And a couple of PhD students. We started off with Jacinta Applin, and now Benjamin Bridgman's doing things. And then we've got the people on the ag research farms as well. And we're sponsored by Beef and Lamb New Zealand as well as ag research. So thanks to everybody there, because some of these trials have been quite major. So I'm just going to talk briefly about the ovine pneumonia background, a bit about vaccination trials and what we're going forward. It's a work in progress, so yeah, well, I can just tell you where we're at the moment. So the main thing about ovine pneumonia is it's costly. Now these figures were done with meat sheep. So by the time we put in the dairy sheep, you know, this figure's probably way out of date. But at that point, it was $100 million per annum. Main thing about ovine pneumonia, it results in the death of lambs and slow growth of lambs. You do get some ewes affected, but not to the main, not so much. So in meat sheep, you've got lamb death, downgrading of carcasses at the works because of pleurisy, and then in the dairy sheep, we've got lamb death, animal production and animal health problems, and then we don't know if there's breed susceptibility. Catherine McRae from Ag Research and Invamate has done a little bit of work and says that there might be some breed susceptibility. Overseas, I've read a very, very, very old paper that said the East Frisians might be more susceptible to ovine pneumonia. Certainly in the meat sheep breeds, the Merinos are more resistant than, say, the Romneys. So it's an area that would be really interesting to find out more on. I haven't been able to find anything more about some of those European breeds, the Lacone breed. So anyway, that's an area for more work. So getting into the main things, okay, what causes ovine pneumonia? The main things that it's caused by, in New Zealand anyway, is a bacteria that's called Mannheimia hemolytica. Closely related to that is Bibristenia trialosi. Mannheimia hemolytica used to be called Pasteurella hemolytica, and that's also related to another bacteria called Pasteurella multocida, which causes shipping disease in cattle. The ovine pneumonia, that Mannheimia hemolytica is also implicated with cattle ovine pneumonia as well. We have Mycoplasma oviepneumoniae that's involved in the infections, and also a number of viruses. They think an adenovirus, PI3, might be involved. So you get a couple of different types of pneumonia. You can get an acute fibrinosis type of pneumonia, and that will be early days in the lamb, and you'll get this sudden death. And it's very acute. The other type of pneumonia that we come across, particularly this time of year, is the chronic non-progressive pneumonia. That's, as it says, chronic in older lambs and hoggets, subclinical sometimes, but the main not the main thing that causes it, but the main thing that exacerbates it is heat stress, transportation, dry, dusty conditions, anywhere where you've got the animal being stressed. So this is probably an area which might be affecting the sheep milking industry as well. So it's the idea is to try and reduce some of those stresses on the animal. Overseas, the causes of ovine pneumonia are a little bit different. We have some different types of pneumonia, one caused by progressive pneumonia caused by a virus called Visna virus and Q fever. Luckily, we don't have those in New Zealand, and all the semen and any animals that come into New Zealand are tested for that because it's a disease we do not want. And just to sort of show what we are actually looking at with pneumonia, if I can make this go. So we've got, quite typically, the infected lobe, or the first infected lobe might be the apical lobe on the right, because that's right at the top. These bacteria that we're talking about that cause pneumonia are usually sitting in the upper respiratory tract, just in very small numbers. Under times of stress, heat, anything dry, dusty conditions, then they get irritated. They sort of start to, the animal gets stressed, and it allows these small numbers of bacteria to get down into the lungs, and the animal can't cope with it. So you get this consolidation in the lungs itself. So there's a picture that shows you the hardening and thickening and hemorrhagic consequence of the pneumonia, where the animal can't breathe. In some animals, you'll get it that its whole lobes are totally affected, but as I say, it normally starts in the right apical. So what can we do about it? Well, what we're doing about it is we're looking at vaccination. It seems to be we hope a cost-effective outcome. So, but the search for an effective vaccine's been going on for many, many years. As I mentioned, Bryce Buddle, Hugh Davies, people like that have been going. Last century, trying to work on pneumonia. Mainly, they were doing work to try and find out what caused it and everything like that. Then, more recently, then it sort of basically was in the too hard basket. I think they looked at vaccines, but they weren't effective in New Zealand. And so in 2015, Tao Zeng from Ag Research, he did a trial and found out that if you made a vaccine from one bacteria, you get cross protection against the other strain. So that was a really important result from there. So from that, unfortunately, then Tao set up this trial, and then he left, and we did an adjuvant trial. Now, with any vaccine, most vaccines have an adjuvant, and that's something that will just make the vaccine work better. So Tao set up a vaccine trial on one of our local farms. We tried 3 different adjuvants, which I'll mention again in a minute. He also went and did a huge field trial vaccinated. In this case, he vaccinated a mixture of lambs and ewes. I think that's really important because that has a big effect later on when we talk about the results. And as a result of that, we then went on last year to look at a trial that combined one vaccine that had against Mannheimia and against Mycoplasma. So then this year we've sort of improved the vaccine, and I'll show you some of the results, which has got Mannheimia, and again it's got Mycoplasma in it as well. So just to let you know what we do in the process of after we've vaccinated the animal, and we want to see if it's got pneumonia or not. We bleed the animal, we look in the serum for antibodies, we record the presence of pneumonia, the type of pneumonia, if there's blood there, if there's hemorrhage. We rinse the lungs out with saline, and then culture that and look for the two main things that we're looking for are this is colonies of Mannheimia hemolytica, so it's a little bacteria, and it's hemolytic on a blood plate, that's why it's called hemolytica. Or the other one is a Mycoplasma ovi pneumoniae, and so that's a Mycoplasma is something that's a bacteria that doesn't have a cell wall, very small too. As well as in the process of after we've cultured these bacteria or not, we also look at histology to see if that is a fibrinous type of histology process or pathology, and then we save samples for future use because we never know when we need to go back. So that was just the lab process, but let's look at some of the a bit more about the field trials and some of the results that we've done recently. So in 2016, the field trial that Tower started set up, there were about 4 farms, close to 3,000 animals. The results showed that there was chronic pneumonia there, and on one farm there was a lot of pneumonia. So, and the results from this one was we found that the lambs from the vaccinated ewes were more resistant to the pneumonia. They had less pathology and they had less of the bacteria that caused the pneumonia. However, from a farming point of view, the carcass weights, the days to slaughter, and the daily weight gain weren't significantly different. So it shows to me that we have improved the health of the animals, but not so that, I suppose you'd say, the return to the farmer. And these are meat farmers, sheep meat farmers. So I can see that in the dairy sheep, if we could improve even the health of the animals, then, you've got a better outcome, because you're not so much looking at the days to slaughter and things like that. So anyway, we had an improved health of the animals, but we needed to improve the vaccine. And we wanted to target the chronic pneumonia, so we wanted to include the Mycoplasma pneumoniae component. So I mentioned that Tower had also set up this adjuvant trial, and that our goal was to find a suitable adjuvant. And the outcome, what we want, something that was a really effective vaccine, but we don't want site reactions, because in site reactions you get downgrading of the carcass. They have to slow down the line, they cut out the vaccination site. So we looked at 3 different adjuvants. We looked at alum, which you might have heard of before. It's in a lot of vaccines. We looked at another one called ISA 61, and that's a montanide-based vaccine, which is also in a lot of animal vaccines. And we looked at one called Quillay, which is made from the bark of a tree. So we looked at all those, and the outcome of it was that we didn't get very good antibody responses with the alum. We got good antibody responses with the Quillay and with the ISA 61, but what we didn't get with the Quillay was the site reactions. So for that reason, we went ahead with the Quillay. So subsequent trials, we vaccinated, last year we vaccinated the lambs only, and we had 25 animals per group. We vaccinated with Mannheimia antigens and with Mycoplasma pneumoniae antigens. We're using the Quillay adjuvant. And then we challenged them, because we wanted them to actually all get pneumonia if they were exposed. We exposed them to pneumonia, so it was the best way we can do it, to get a representative sample. So the result, unfortunately, was that we didn't get any antibody response to the Mycoplasma. So, okay, we got some responses to the Mannheimia, but we want a vaccine that's going to be effective against both. So this year we've vaccinated lambs only, again 25 animals per group. We've increased the Mycoplasma antigen concentration, because we got nothing last year, no response last year. And we've increased the proportion of the adjuvant, and we've challenged them. So I just want to rush through briefly showing you the type of challenge trials, what we do. So we have 20 groups of 25 in each group, and there we always have a control group, and we had a group that had Mannheimia vaccine and the Mycoplasma vaccine, and then we had a third group that just got the Mannheimia alone. We vaccinated all the animals at twice monthly interviews, bleeding them so that we could test for antibodies, and weighing them, because we want to see if we're getting better weight responses. We then, 1 month after the second vaccination, we challenged them with the virus and Mycoplasma, because it's thought that what happens is that you get the viral, particularly viral infection or Mycoplasma, will start to cause some damage, which allows a secondary effect of the Mannheimia to get in and cause really bad pneumonia. So we infected 1 week, and then a week later we infected with the Mannheimia, and then we euthanized the lambs a week later. So this is testing for an acute type of response. And we bleed the animals, and I said lungs were sampled. So I'm just this will be the main sort of response slide, and it shows just that in 2015-16 we got some, and there were separate vaccines, each of those vaccines at the top. There's a separate Mannheimia vaccine. Oops, did it. Separate Mannheimia vaccine and a separate Mycoplasma vaccine. It showed that we could, if we combined them, because we got antibody responses, we could do it again. Last year we didn't get a antibody response. This year we've got an antibody response with both, and it is a combined vaccine, so it's looking promising. The graphs at the bottom are showing you that the control groups at the bottom, they are not responding, they're not producing antibodies until they're challenged, so that these animals are trying to make a response. By that stage it's probably too late. And that was with the Mannheimia vaccine, and that was a combined one, responses to Mannheimia. This is a responses to the Mycoplasma, and only one of those animal groups got their Mycoplasma, so that's the one that's responded. So it's just showing we've got a good antibody response. We are still doing processing all our samples going forward. We'd like to incorporate in genetics. But the things, I think, these future trials, which we'd really like to get involved with, and I'm thinking that maybe the sheep industry, the milking sheep industry would be a really great place to start with this too, is to vaccinate the ewes and the lambs, because, as I said, these last two trials, we've just been vaccinating ewes. The previous trial that first started, it was the ewes that were if you vaccinated the ewes, you got a better antibody response that was protective, because the ewes produce the antibodies, pass it on to the lambs, and that protects them when they're exposed to the pneumonia. So I think that's mainly the key. And also maybe we need to increase the time between vaccination from one booster to the next, and it can be up to a year later. It's just convenience why we did a month, And of course, a multi-year study. If you vaccinate a ewe and it's boosted every year, doesn't mean the progeny each year will be better, because it's the ewe is producing more antibodies. So yeah, it's really exciting if we can continue forward. But of course, like anything, we need to have some, if we can get the funding for this to continue. So just there, that's our Rangi farm where we did some of the work, and then the Hopkins Institute where we do the lab work. Thank you very much.